Welcome to my project bazaar.com. Here we are going to discuss about the effective and efficient approach for power reduction by using multi-bit flip-flops. In this project mainly focused on the elimination feature of the redundant invariance in merging a single bit flip-flop into a multi-bit flip-flops gives reducing of wire length and this result in reducing of power consumption. With the growing popularity of portable devices, power interaction has become a more popular design tool for advanced design applications. Multiple flip-flop is an effective power-saving implementation method by merging single-bit flip-flop in the design. Using multiple flip-flop can reduce clock dynamic power and the total flip-flop can effectively. In this paper, we propose a arithmetic clustering algorithm to find the nearest clustering of flip-flops for merging the flip-flops. This algorithm finds the clusters of flip-flop and finally combine the flip-flops to reduce the wire length. We can see the flip-flops and click trees accountable for large proportion of power consumption. Although the power distribution will vary with the different ASIC design, reducing power consumption of the flip-flop and the clock tree can eliminate total power consumption efficiently. Multi-bit flip-flop is an effective power-saving implementation methodology by merging single-bit flip-flops in the design. Using the multiple flip-flops can reduce clock dynamic power and the total flip-flop area effectively. The legal placement region of the flip-flop it can be obtained by the overlapped area of these regions. However, because these regions are in the diamond shape, it is not easy to identify the overlapped area. Therefore, the overlapped area can be identified more easily if we can transform the coordinate system of cells to get rectangular regions. In the second stage, we would like to build a combination table which defines all possible combinations of flip-flops. In order to get a new built flip-flop provided by the library, the flip-flops can be merged with the help of the table. After the legal placement region of the flip-flops are found and the combination tables is pulled, we can use them to merge the flip-flop. To speed up our we will divide a chip into several bins and merge the flip-flops in a local bin. However, the flip-flops in different bins may be mergeables. However, we have to combine several pins into a larger bin and repeat this step until no flip-flop can be merged in our proposed system. We propose a arithmetic cluster algorithm to find the nearest clustering of flip-flop for merging the flip-flops. The algorithm forms the cluster in a bottom-up manner. Initially, put each article in its own clusters. Among all the current clusters, pick up the two clusters with the smallest distance. Replace these two clusters with a new cluster formed by merging the two original ones. Repeat the above two steps until there is only one remaining cluster in this full. The algorithm finds the cluster of flip-flop and finally combine flip-flops to reduce the wire length. This is our system flow diagram. This flow diagram represents the flow of our process. First of all, we give the initial flip-flops into our selective activity flip-flops. In this selective activity flip-flops divided into the number of cluster flip-flops. In this cluster flip-flop separated by the distance basically. If distance is minimum, send to the create table and directly find out the output. In case of a large amount of distance, we form into the merging cluster. Merge clusters is not a matter to merge the two flip-flop into a single flip-flop. This is called a merge clusters. Then again after the merge cluster, we calculate the remaining clusters how many of that. In case of multi number of remaining clusters are there, again we form the merge clusters. Then finally we give it to the create table. The create table count how many number of clusters formed. Finally we get the merged output. Now we are going to discuss about running procedure of our project. In our project we have 4 steps. First step we check the syntax error, then second step we generate the RTL schematic diagram, then third step we generate the technology schematic diagram, then finally we generate the simulation waveform. First select implementations, then select view check syntax. Now we are going to check the syntax error of our program. In case of any error displayed in our console block, in our program we have no errors. Therefore now we are going to the second step. select view RTL schematic and run that and add and create schematic. This is our overall RTL schematic diagram. Data in, clock, read, reset, write. These all are the input signals. Q, empty, full. These three signals are our output signals. This is our internal block diagram of RTL schematic diagram. Now we are going to the third step. Select view technology schematic and run that. Add, create schematic. This is our overall technology schematic diagram. This is our internal technology schematic diagram. In this technology schematic diagram consists of number of LUTs and flip-flops. Now we completed three steps. Now we are going to discuss about the final step. Please select simulation and select main function and select simulate behavior model and run that. Now we give the input values. Clock value set to 0, reset value set to 1 and write value set to 1, read value set to 0 and data in give any random number and run our program. Then again we change the clock value set to 1 and run our program. This is our reset condition value. Now we change the value reset to set to 0, write value set to 0, then give the read value set to 1 and clock value change it to 0 and run that. Now we change the clock signals only. Again we give the clock values and run. Then again change the clock values. Then again change the clock value. Then again change the clock values and run our program. And now we generate the simulation waveform. This is our overview of simulation waveform. Now we complete our running procedure. Thank you.